Welcome. This is Saravanan, Assistant Professor, Department of AI&DS, working in KIT, Kalinga Karnataka Institute of Technology. Today I am going to handle the subject Design and Analysis of Algorithm. Topic is Branch and Bound Techniques. So what is branch and bound technique? So in this method, a state space tree of all possible solutions generated. Then partitioning or branching is performed at each node of the tree. For every node we have to perform the branching node. For every node a branch bound is computed or calculated. This bound value is compared with the value of the best solutions obtained so far. The bound value is compared with the value of the best solutions obtained so far. Each time a node's bound value is compared with the current best solution. If the bound value of a node is not better than the best solution, then the corresponding node is not expanded further. Such a node is called the non-promising node, and the search is terminated at the node. The process helps in reducing the unnecessary computations. So reason for terminating the search path in the state space tree for the branch and bound: the value of the node is not better than the best solution. We are comparing with the best solution, so the value of the node bound is not better than the best solution. First reason. Second, there is no feasible solution. Third reason, a new better solution can be obtained rather than continuing further node. So LIFO search and FIFO search. The branch and bound creates a state space tree by discovering the branches that need to be expanded in order to limit the number of possible solutions. The branch and bound method makes use of estimated bounds. So there are two types of strategy. One is LIFO, another one is FIFO. LIFO stands for the last in first out. This search is based on the depth first search technique, in which a branch is extended through the first child discovered at the certain depth until a leaf node is reached. Here we use the stack data structure. FIFO is first in first out. The oldest node in the queue always used to extend the branch. Here we are using the birth first searches, where all nodes at the depth t are visited. The first before in nodes at the depth t plus 1 are visited. The queue data structure is used in the search. So assignment problem. So example for the branch one. First problem is assignment problem. There are n peoples and n jobs. Each person has to assign exactly one job, and each job must be assigned to only one person, such that the total cost of the assignment is minimum. The assignment problem is represented using an n cross n cost matrices, where each element indicates the cost of assigning a particular person to a particular job. You are going to assign the cost of assigning a particular person to a particular job. One element must be selected from each row. We are selecting each and every row with one element, ensuring that no two selected elements are from the same column. The main objective is to minimize the sum of the selected elements. Let us consider an example and understand the problem. Job 1, job 2, job 3, job 4. Here the person B, A, B and C and D. We are going to select the minimum problems here. From the problem we are going to select the minimum value from each row. Here from first row we are selecting the minimum 10 to 7, 8. The minimum value is 2. I select the minimum value 2. Second row the minimum value is 3. Select the minimum value 3. Third row minimum value is 1. So select the value 1. Fourth row minimum value is 4. So I have selected all the minimum values from all the rows. The total value is 10. So this is the lower bound. So lower bound value is equal to 10. We have to compare the each and node with this corresponding bound value only. So first I starts with the lower bound value 10. I am going to select the value a equal to 1. A equal to 1 means first value I am going to select the first value here. Then a equal to 2, a equal to 3, a equal to 4. A equal to 2 means here the lower bound is equal to a equal to 1 means I am selecting the first value. First value is 10. So 10 is the first one. Remaining 1 we have to choose the minimum value. Upon 10 plus 3, 13. Then we have to choose the minimum value. Okay, 13 plus 1, 14. Then minimum value 4, 18. So minimum value is here 18 only. So we have to choose the minimum value. So same like we have to choose the a equal to 2. We are choosing the second value, second column here. A is equal to 3 means choosing the third column. A equal to 4 means choosing the fourth column. So compare with this least node, lower bound node. Here the lower bound value is 18. Here is 10. So we are going to prove the corresponding LB is equal to 18. So let us see the example a equal to 10. Here the lower bound value is equal to 10. We are choosing this element only. I have selected the second element because this element is compared with this element is mostly possible solution only. Here lower bound value is 20, so I am going to prove the value. Here the lower value is equal to 18. I am going to prove this value. Okay. So this node is known as the promising node. Further it can be extended the value. Again I am going to choose the value b equal to 1. B equal to means choosing the second value. First value I have chosen the a equal to 2. Again going to choose the b is equal to 1. So first value choose the a equal to 2. Second value choosing the b equal to 1. This value 8. Okay. Then again 2 plus 8. 2 plus 8 I am choosing the value 2 plus 8. Remaining value is minimum value 1 plus 4 here. So total bound value 14. Here choosing the b is equal to 3. Third value I am choosing. So third value means first, second, third. First value a equal to 2. Second value the person choose the value 2. Person B choose the value 3. Okay. Third value we have to choose this value only. Minimum value is 8 is compared with the 5. 5 is a minimum. Again 4. So total bound is equal to 14. Again b equal to 4. Choosing the fourth value here. Fourth value. So a equal to 2. Okay. Choosing the fourth value. B equal to 7 here. So 2 plus 7. Remaining minimum value is 1. Again 7. 17. So compare with the lower bound. Okay. Compare with the lower bound. It is this value b will be largeable 17. Compare with the 17 is more largeable element. So we have to compare this element only. B equal to 1 and c is equal to 3. So b is equal to 3 means we can get the element here. So this only the lowest element, because the lower bound is 13 only. Here 14 and 17 we are going to prove these elements. We have to select this element only. So person a equal to 2, person b equal to 1. Then we have to find out person C which one is selected, person D which one going to select. So I am going to further extend this node only, because these nodes are not feasible. This node also not feasible. So this node only feasible. So I am going to extend a equal to 2, b equal to 1. Here I am going to use the value c is equal to 3. Here I am using the value c is equal to 4. Suppose I am going to use the c is equal to 3, a equal to 2, b is equal to 6, c is equal to 3. 3 means 1. Okay, again for 1 d is equal to 4 here. So 2 plus 6 plus 1 13. Suppose I am choosing the value c is equal to fourth element. Here fourth element means I can choose the value 8. Then remaining value is 10 only. So here the lowest bound is not applicable. So here only the lowest bound is applicable. So it is a solution because we have got the minimum values from each column. No value selected is under the same column. Thus the assignment problem can be solved with the best fit branch and bound algorithm. So let us understand some commonly used terminologies in the branch and bound techniques. Here choosing the live node. The live node is nothing but it is a node in the state space tree which is a promising node and can be further expanded in order to get the final solutions. This is only the promising node. Okay, this is promising node. This is known as a live node. Then best branch and bound. There are searching strategies which are adopted in order to find the optimal solutions from a state space tree by means of expanding this promising node. This promising node expand to find the solutions. This node becomes a promising node. Okay, further we can extend that node, the promising node. Thank you.